Okay, so what we are going to do, we are going to look at a number of questions that you need to practice. So like the first question is, let me see, why is this not working? Let me see. What ions are present in the following compounds? So the first one is KBr. So if you look at this compound, there are two ions. There is K, there is Br. So K is in group 1. So because K is in group 1, the ion will become K plus. Br is in group 7. So the ion will become Br negative. So we have these two ions, K plus and Br negative. What about in here? MgCl2. In this, Mg is group 2. So the ion itself is Mg2 plus. Cl is group 7. So the ion is Cl minus. So these are the two ions present there, Mg2 plus and Cl minus. Now we have aluminum O3. So here aluminum is in group 3. So we need to put A here. Here also A, here A. All these groups are A. So aluminum is in group 3A. Therefore, the ion will become Al3 plus. Oxygen is group 6A. So the ion will become O2 minus. So aluminum oxide has these two ions, 2 minus. So that's how you want to answer this type of question. Let's go to the second question. What is the charge on each of the ions in the following compounds? Now here we have Zn OH2. So for this compound, we know that, let us write it like this: zinc here, then OH2. We know that each OH has a charge of negative, but here you have two of them, so it will be, if you want to talk about the charge, zinc here, OH2. Since you have two of these, but each one has a negative one, so you are going to have 2, 1 charge, because there are two of them, which gives you -2. So we can say that if we write zinc OH2, the charge here for the OH is -2. And because OH has -2, zinc must have +2. But we know that each OH has a -1 of charge. We already know that. So the ion present in here is zinc 2+ and OH-. So these are the two ions present. Then we have another problem. Let me just get rid of some. Let's see another compound. Another compound, so I'll put P here again. Another compound is SnCl4. So what is the charge of each ion? So first we know that chlorine is in group 7. So the chlorine here is Cl-. So each chlorine is Cl-. But if you look at CnCl4, there are 4 of these chlorine. So we have 4 minus 1, because we have 4 chlorine. So in the end, you are going to have is it still working? Let me see. Yeah, it is. So let me just get rid of something. Erase here, erase here. It's not zinc, it's tin. So I'll put S here, S here. So tin Cl4. If we multiply this and this, we find that we have -4 here. So if you have -4, you must have +4 on the tin. So the ions we have are tin 4+ and chlorine -. So these are the ions present in this compound. So these are the two ions present in tin and chlorine. So here, just take note that we have 4 chlorine, not just 1. each chlorine here is -1. So you have to multiply by 4 to get the total charge of chlorine. Once you get the total charge here, this is equal to the total charge on the tin, which means we have tin 4 plus and chlorine 1 minus from here, because we know from the periodic table that chlorine is going to be 1 minus or -1 charge. Let's go again and check another molecule. V2O5. So what is the charge of each ion? So for this one, the simpler way is just to take the 2 here and put it here, and take this 5 here and put it here. So you need to know that the V becomes 5 plus and the O becomes 2 minus. So our charges here are V 5 plus and O 2 minus. You need to remember that always we have a metal and a non-metal when talking about ionic compounds. So let's also practice another atom. What about here? What is the charge of Cr? What is the charge in each of these atoms? So for this one, we know that oxygen is in group 6. So oxygen has a charge of -2. So what we are going to have here we have 3 oxygens. So you are going to write Cr(O3). So this one will be 3 times 2, because the charge of each oxygen is -2, but there are 3 of them, which gives us -6. So you are going to have Cr(O3) -6 here. So if you have -6 on top of oxygen, it means you have +6 on top of Cr. So the charges are as follows: Cr 6 plus, O 2 minus. So for oxygen, we get the charges from the periodic table. So we get charge from the periodic table because we know that oxygen is in group 6. Therefore, it will have a charge of -2. So once you do that, then you know that there are 3 oxygens here. You just multiply 3 times -2. Then you get -6 here. And then if you get -6 here, it means this one you have +6. So that's how you look at that problem. Now, what about the charge for copper, then CH3, CO2? So if you see an ion like this one, you need to separate it into two groups, metal and a non-metal. If you see a compound like this one, you need to separate it into two groups, metal and a non-metal. So let's see. This part is metal, copper, we know copper, and this part is a non-metal. So where do we get information? We are going to use the non-metal from the table that I gave you of the ions that you need to memorize. We are going to use the non-metal to tell us about the metal. So we are going to use the non-metal to tell us about the metal. So what we are going to do is I know this non-metal. I know that CH3 CO2, this is an acetate, has a charge of negative. So the ion itself is known as acetate. So it has a charge of negative. So if you put it in there with the copper, you have -1 for the non-metal. Therefore, you are going to have +1 for the metal. So if you think about what ions are present in this case, so the ions present will be copper plus and the acetate ion. So you can see that we have used the acetate ion from tables to give us the charge of the copper metal. Now what about here? What is the charge of the ions BaSO4? So for this one, because Ba is in group 2A, right? Which means Ba has a charge of +2. So based on that, we will look at Ba. We just write something like this: BaSO4. This part is +2. So if Ba is +2, it tells us that SO4 is -2, because the ions must cancel each other. They need to have the same charge for them to be, for the compound to be neutral. So what does it mean? It means that the ions present are Ba2+ and SO4 2-. So these are the ions that are present in this compound. Let's look at another compound. Li2CO3. So to solve this problem, lithium, so Li is in group 1A. So lithium is in group 1A. Therefore, lithium will have a charge of Li plus because it's in group 1A. So, but here we have two lithium atoms here. So the lithium atoms, we have two of them. So this should be 2 times plus 1 only for the lithium part. So in the end, the lithium part will have plus 2 because we have two of them, which means the carbonate part will be minus 2. So if I continue here, I will see that each of the two lithium atoms has a charge of plus, and the carbonate ion has a charge of 2 negative. So take note that the lithium does not have plus 2. Plus 2 is for two lithium atoms, but each lithium atom has plus 1. So let's look at magnesium sulfate. So Mg is in group 2A. So because Mg is in group 2A, the ion is Mg2+. So what we are going to do is we are going to have Mg here, SO4. This one is 2+. Therefore, this whole thing is -2. You need to make sure that the charges balance. They need to have the same charge. So the ions present, we have Mg2+ and SO4 2-. So let's practice on another ion or another ionic compound. We have KH2PO4. So that is a compound that we are dealing with. Now, for this compound, you need to identify where the metal is, where the non-metal is. So, our metal in this compound is K. So this is the metal, potassium. So the rest of this is non-metal. So make sure that you recognize the metal and then you can identify the non-metal. So based on that, what we are going to do is we know that K is in group 1. Therefore, the ion will be K plus. So the ion that it forms will be K plus. Now, so you can write this again, this ion again, PO4, this part is +1. For this ion to be neutral, it means the whole of this part is -1. So the ions present are K plus and H2PO4 minus. So these are the ions present in this case. In this case, we have used the metal to determine the non-metal. So we have used the metal to determine the non-metal. That's what we have done. Let's look at the last one from this video. What ions are present? So let's look at this one. Sodium nitrate. So here we know this is our metal, and we know that it is in group 1. So Na is in group 1. Therefore, its charge is Na plus. So we can say this one, NO2, we know that this is +1. Because this is +1, therefore the non-metal part is -1. So we can say that the ions present are Na plus and NO2 minus. So that's how we obtain the ions present in a molecule. Now let's see more problems that we can solve. I think I'll just add 10 minutes there to see more problems that we can solve. So here, another question is, what is the formula of the following? So here we have lithium and iodide. So to solve this problem, the first thing you need to know the group number. So lithium and also the symbol, right? So lithium, you know that lithium is written as Li. The iodide is written as I. So that's the first thing. You need to know the symbol of the elements. Now, group. Lithium is in group 1. Charge. Therefore, lithium has a charge of +1. Iodine is in group 7. Therefore, it has a charge of -1. So what you are saying is we have a charge combination of Li plus and I minus. So because we have plus 1 minus 1, they cancel each other. Our compound is just Li and I. So that is lithium iodide, or lithium and iodine. Let's look at another problem. We have rubidium and fluoride. So the symbols are rubidium is Rb, fluorine is F. Group rubidium is in group 1, fluorine is in group 7. The fluorine is in group 7. Charge, this one has plus 1 and this one is minus 1 because it's in group 7. So which means our compound is Rb plus and F minus. Those are the charges. As we said, the plus and minus will neutralize each other. We just have Rb F. So that's the compound, rubidium fluoride. So another compound is, so remember, we are writing formulas. So write formula of compounds. So remember, we are writing formulas. So here, strontium and chloride. So again, just go to the periodic table and see where strontium is. The symbol for strontium is Sr. The symbol for chlorine is Cl. Group strontium is in group 2, chlorine is in group 7. So being in group 2 here, the charge will be plus 2. For the chloride ion, the charge will be minus 1. So really, bringing together these ions, we have Cr 2 plus and Cl minus. Now, to write a compound, I need to cross this. So the negative, the one here goes down here to strontium, and the 2 goes down here on the chloride ion. So the compound I am going to have is SR. So let me get rid of the so the compound I am going to have is SR1, then Cl2, but you don't show 1 as a subscript. So actually the final compound is SrCl2. So don't show 1 here. So I'll continue this in the next video.